Okay, we're doing lesson 2.3 in AP Calculus curriculum, estimating derivatives of a function at a point. Our learning objective today is to estimate derivatives. Our essential knowledge, derivative at a point can be estimated from information given in tables or graphs, and technology can be used to calculate or estimate the value of a derivative of a function at a point. So, first we're going to start by looking at a graph and how we can use a tangent line to estimate the derivative at a point. When we look at this function, we have a function graphed f of x, and it says the tangent line is shown below. It appears that the tangent line, point of tangency is the point 4, 6, and it also appears that there's another point 2, 2 on the graph of that tangent line. So we could come up with the equation for the tangent line, and if we came up with the equation, the slope of that would be, but we can also just use these to estimate the slope of the tangent line. Recall that the derivative of a function at a point is the slope of the tangent line at that point. So we're going to take the points. We have 4, 6, and we have the point 2, 2. And we're going to find the slope because f prime of 4, the derivative of f of x at x equals 4, is equal to the slope of that tangent line. And we know the slope of that tangent line is y2 minus y1, y2 minus y1 over x2 minus x1, x2 minus x1, which gives us 4 over 2, or the slope is 2. So f prime of 4 is 2, if that's the tangent line, if we have taken that and estimated it. Now let's look at what you did on your pretest, because there were interesting ways they found to ask these questions. We looked at this question. I'm going to cut this out so I can draw on it. And it said we want to look at the graph of the function f, where f of b is less than or is greater than f of a, and a is less than or equal to x is less than or equal to b. So that means the function is defined between a and b on the graph. The derivative of f exists for all x in the interval a to b except x equals 0. And for how many values of c, for a is less than c is less than b, so c has to be between a and b, does the limit as x approaches c of f of x minus f of c over x minus c equal f of b minus f of a over b minus a? Well, this difference quotient is just the slope of this line that connects those 2 points. And recall, this is the derivative, the limit definition of the derivative at a point C. So what we want to know is where on this graph, how many times on this graph must the tangent line, the slope of the tangent line, be the same as it is for the difference quotient f of b minus f of a over b minus a. Let's look at there's a tangent line there. They'll be parallel to that line. There's a tangent line there. It will be parallel to that line. There's a tangent line there, close enough. And there's a tangent line there. And that looks like all, so the answer here should be 4. Let's look at the next one on that pretest because it was similar. This is another one that's similar to that. We'll do the same thing. The graph here, f, where f of b is greater than f of a. So that means this y value of this point is larger than this y value of this point. A is less than or equal to x is less than or equal to b, so x is contained in the interval. Derivative of f exists for all x in the interval except x equals 0. And for how many values c, where c is in between a and b, does the derivative at c equal the difference quotient, which is the slope of the line connecting those 2 points. So let's look and see how many times that must happen. looks like there'll be a tangent line that'll be parallel there, a tangent line that'll be parallel there. If that's the same tangent line, let's see, there's still a C value there, a C value there, a C value there, and another C value here. So again, it looks like 4 times. Everywhere the tangent line's parallel to this secant line, where the slope of this secant line is the difference quotient, then the slope of this tangent line and this tangent line and this tangent line are all the same. And that means that the derivative at all those points where that intersects are the same. So there were 4 C values of x in that interval. So there are 4 times. And that's part 1, how we use tangent lines to estimate the derivative at a point on the graph of f of x.